most of us are using IT services and consuming IT services, which we rightfully expect to be always on. These could be services like your internet banking services, your mobile banking services, your e-commerce services, or online shopping services. The expectation is that these services will never effectively fail. If you are a provider of these services, then resilience is more important and more critical than it has ever been. Even a few minutes of system downtime can cause millions in lost revenue and potentially irreparable reputational damage. If you are a firm that is operating in the highly regulated industries like financial services or healthcare, operational resilience is no longer just good practice. It's absolutely fundamental for you to demonstrate that you are compliant with the relevant regulations, and it enables you to build trust with your stakeholders and your customers. So good afternoon, folks. My name is Harish Nandwani. I'm a senior solutions architect. I work in AWS with financial services customers, helping them design, build, and operate highly resilient systems. I'm also the global lead for chaos engineering competency and the technical field community in AWS. And today, me, along with my colleague Vikas Gupta, we will be talking about DORA, which is an EU-wide regulation focusing on operational resilience, and how you can use the AWS Fault Injection Service to address a very specific requirement within DORA that needs you to perform scenario-based testing.
Thanks, Harish. Good afternoon, everybody. My name is Vikas Gupta. I'm a solution architecture leader at AWS. I and my team take care of the capital market segment here in the UK. So today we are going to talk about DORA scenario testing with our AWS Fault Injection Service. We just want to do a pulse check here. With a show of hands, how many of you have system resiliency as one of the key priorities in this year? Wow, great. A lot of hands. And how many of you are looking to comply with Digital Operation Resilience Act? Congratulations, you all are in the right session. Everybody who has raised the hand and not raised the hand, we are going to talk about DORA and resiliency in the session. So let's begin with an overview of DORA. So DORA, or Digital Operation Resilience Act, is a pan-European framework on resilience, especially on operational and cyber resilience, that brings new regulatory requirements. And these new requirements impact how financial entities work with third parties, especially the cloud service providers. DORA can be seen as a framework with 5 pillars. The first pillar is about Information Communication Technology Risk Management, or ICT risk management. This allows financial entities to implement comprehensive risk management framework that includes setting up or defining the risk tolerance level, or assessing the risk, identifying the risk, managing them continuously, and also having a mitigation approach for all the risk that you are identifying. The second pillar is about ICT incident management. It is a framework to make sure that financial entities are doing the management of the incident and also reporting to their national supervisory authority. It includes sending the initial notification and intermediate report, and also the final report of incidents. The third pillar is about third-party risk management. For any financial organization, third-party are those vendors and service providers who support their critical workload in DORA's framework. So this includes the cloud service provider, but also the subcontracting parties. So this pillar allows financial entities to continuously manage the risk associated with using the third-party services. The fourth pillar is about information sharing. DORA encourages financial entities to share information, especially the trusted information in trustful community. For example, sharing the vulnerability intelligence information and similar information in the trusted forums. This encourages collaboration. And finally, the digital operation resilience testing, which is to make sure that financial entities are prepared for any unforeseen scenarios, and they have a framework to assess and conduct the resilience testing. And this is the part of the thing that we want to talk here. So as part of the DORA requirement, the DORA requires financial entities to implement a comprehensive testing program that includes the scenario-based testing. Now, you might be thinking, what is scenario-based testing? So scenario-based testing is a simulation of those critical scenarios that could lead to some kind of failure or disruption in their critical environments or to their business as well. And that includes their operations, services, and functions. So scenario-based testing allows you to do 4 things. The first is proactive risk management, which is about the pillar number 1 and 4 that I just mentioned. So it allows financial entities to think proactively about the risk, not only just thinking about the past incidents, but also thinking what could happen in the future in the ongoing challenging environment where everything is so connected and the threat landscape is always evolving. So you may see cascading effects of previous incidents. You might also want to gather information from your line of business to make a comprehensive risk management framework. Second is about testing the critical functions under stress. Now, in the digital world, it is important that you check how your system behaves under stressful condition. And those stressful conditions could be injected in a controlled environment. And it could be like any critical infrastructure failure or any application configuration issue, or it could be a human error. So you want to make sure and see what is the breaking point of your system and how does system react when it reaches the threshold. The third point is scenario-based testing allows you to document your processes and make it auditable, which is quite important from DORA point of view. It allows you to document all the scenarios that you want to test comprehensively, and also what would be the steps of those testing, what would be the lesson learned, and what sort of mitigation approaches you will find when you test those scenarios and when you plan for their resolution. And fourth is testing the dependencies. In this digitally connected world, there could be dependencies internally and externally. And you want to make sure that you test those dependencies and see how system react when any of your external dependencies like third-party cloud service provider, if you get some kind of disruption, how does that system react? So you want to do the upstream and downstream dependency check. So these are the 4 things that we believe scenario-based testing allow you to do. Now, all of you who might be working a lot on system resiliency, you might be thinking, oh, it sounds like chaos engineering, right? So let's see how it is linked to the chaos engineering. Chaos engineering is a disciplined approach that allows you to test and find the failures in your system that could become big outages. And you do that by intentionally injecting some controlled disruptions and see how your system behaves. And it is about bringing those stressed conditions, for example, bringing some kind of network latency or maybe terminating an instance. We have seen by working with our customers that it brings a lot of benefits. So the first benefit is about increasing or improving the efficiency, resiliency in performance and security of your workloads. How do you do that? So for example, you want to create or inject any stressful condition like terminating an instance or bringing some kind of event of network latency or creating some kind of intentional controlled security event. And then you figure out how your system behaves, what are your gaps, how do you want to mitigate all those risks and failures that you have detected. And it helps you in attaining the operational excellence. Because in order to have operational excellence, you need to have a good understanding of your system about the performance, resiliency, and security. And you continuously work on that. The third is, with the help of chaos engineering, you should be able to expose some blind spots. How do you do that? With the help of observability. You make sure that you have those tools that can monitor your thresholds and collect the logs and make sure your alerts are working and responding as well as notifying to the right people or the functions. So this helps you find the blind spots. And also, it avoids resilience regression. Because as the system gets brittle, it gets more complex, and you want to make sure that the fixes that you have done in the past for your previous incidents, they continue to work. But also, if you're launching new services or new feature, they shouldn't compromise any kind of resiliency in your system. So it avoids resilience regression. Now, Harish, you have worked with a number of customers and helped them in implementing the chaos engineering. How do you see them differentiating between chaos engineering and regular resilience testing?
So, chaos engineering as a testing mechanism is frankly very different from any other kind of testing you potentially currently do. And one of the biggest differentiators is that chaos engineering is about running experiments. These experiments are effectively validating your understanding of the resilience of a system. So these experiments, by definition, are non-deterministic. So you don't actually get a pass or a fail when you run an experiment, but the expectation is that you understand more about the system than what you knew before. Secondly, chaos engineering is a lot about exploring about how your system actually handles failures. So again, back to one of the points that Vikas was making, most common critical systems, they are highly complex, they are probably distributed, you have multiple dependencies, and when one element of the architecture has a failure, how does the system actually manage that failure? How does the failure propagate across various components of the system? That is something that is not always easy to understand when you're designing the system. You might have an understanding of how the failure might propagate across your system, but really the best way to understand how the various components in your system will react to failure is by testing it. And that is what chaos engineering is all about. And again, one of the things that Vikas mentioned about the blind spots, chaos engineering is great at understanding the unknown. So effectively, these are things that you're not only not aware of, and because you're not aware of, you don't know about what's the impact of that is going to happen on your system. So understanding those blind spots is a really, really critical output that you can get from chaos engineering. And as you run more and more of these chaos experiments, you learn more about the behavior of the system. So the entire purpose of chaos engineering is to get you to a state where you have a better understanding of the resilience posture of your system. So it's a continuous learning exercise. And then the word continuous means that we are expecting you to actually use this as an iterative mechanism. So it's not just about running your chaos experiments once in your development life cycle, but the expectation is that you will actually continuously run your chaos experiments. And again, back to one of the points that Vikas made, one of the benefits we see customers achieve with chaos engineering is that they avoid resilience regression. A complex system, the resilience of a complex system is not a static thing. It changes almost continuously as you make changes, as you fix bugs, as you make improvements and new features get rolled out. So by doing this on a continuous basis, you are actually effectively getting a better understanding of the resilience posture of a system and avoiding resilience regression. And then automation is a very big thing for AWS. We want customers to automate pretty much everything they can, and this is no different. So chaos engineering, again, we are very keen that you basically automate as much as possible. Now, most customers, if we have implemented a DevOps practice, then you already have continuous integration, continuous development pipelines built. Our recommendation is that you do not include your chaos experiments within your existing CI/CD pipelines. You basically extract them out into something we call the chaos pipeline. And the reason for that is back to the first point I mentioned. Because chaos experiments are quite non-deterministic in nature, you don't want to disrupt your existing CI/CD pipelines with something that you are not completely sure what the impact of that experiment is going to be. So, I mean, based on all that you've heard, again, as Vikas mentioned, the term chaos might sound like there is no real formal method for executing chaos experiments. And to kind of address that particular misconception, what we have come up with is we've come up with the chaos engineering flywheel that you see on the screen. So the way you use this flywheel is that for every experiment that you conduct, you can use the flywheel. So you basically start off with a steady state. And a steady state is basically where your system is performing as you've designed it to perform. So effectively, say you've designed a system to perform at an X amount of processing or able to able to provide X amount of latency, your system is running with exactly those parameters. So you're able to measure your system, and your system is doing exactly what you've designed it to do. So you start off with a steady state. And to make this real, we'll kind of consider the example of a payment system. So for example, if you are operating a payment system, this is potentially a business critical payment system that is processing, say, 1,000 transactions or 1,000 payments a second. And it is expected to also support a mobile banking channel, which expects that every payment that's initiated is responded to within 2 milliseconds. So the payment system has to respond with a 2 millisecond latency for every payment request it gets. So when it's operating at that with those parameters, that is the system's steady state. The next thing is you define a hypothesis. A hypothesis is basically your understanding of the resilience of your system. So again, let's consider the example of the payment system. If the payment system is a business critical system, then it's highly likely that it will be deployed across multiple availability zones. So for folks who are unaware, availability zones, or AZs as we call them, each availability zone is one or more discrete data centers with separate and redundant power, networking, and connectivity. And the way they've been designed is that they avoid the impact of a shared fate scenario. Like for example, if there's localized flooding, then a single AZ, the impact will be on a single AZ and not across multiple AZs. So our recommendation, if you are building and deploying something business critical, is that you look at the multi-AZ deployment pattern. So you will potentially deploy this payment system across 2 AZs. Now, what happens if one of those AZs has an issue and it is impaired? So from your perspective, you followed our best practice, and your hypothesis will be, well, I've designed this using multi-AZ principles, so if one AZ is impaired or unavailable, the system will continue performing as I've designed it to perform. So that's the hypothesis. So we expect no impact to the system. The only way to actually verify this hypothesis is to test it running an experiment. And that is what you do as part of the next step. So you run an experiment which basically will simulate the impairment of an availability zone. Now, luckily for you and for us, you can't yourself impair an AZ. So what you can do is basically simulate conditions like, for example, a power interruption within an AZ that could impact an AZ's availability, and then you can test your application against that particular scenario. So once you've done that, you look at the output and you verify what you see. So ideally, if the hypothesis has been proven true, what you will see is that the system continues performing as is. But in this case, what we see is that the system processing was reduced by half. So effectively, the hypothesis has been disproven. And what that basically means is that you've identified an improvement, a resilience gap in your architecture, something that you need to fix. And once you improve and you fix it, then you iterate. So that is effectively how we typically expect customers to use this particular chaos engineering flywheel. Hopefully, again, from all we've been talking about in terms of the benefits of chaos engineering and the way it is actually executed, there you can see parallels between what chaos engineering provides as a mechanism and then what the DORA scenario-based requirements are. So, because how are we recommending customers adopt chaos engineering for DORA scenario-based testing?
Thanks, Suresh. As an AWS or as an Amazonian, we love flywheels. We love iterative versions because we believe that in order to get to perfection or excellence, you need to have an iterative model. You need to continuously learn. So great seeing another flywheel. But now, in terms of DORA, we are helping a lot of customers in making them enabling them in meeting the DORA requirements. And we have come up with an iterative approach again, because we believe that there is an iteration that needs to happen to learn how to meet those DORA requirements with the help of scenario-based testing. So in the following slides, I'm going to talk about that iterative approach. So the first stage is about identifying the failure scenarios. As with any project or with any problem solving, you first start identifying what are the critical functions that you want to test. So as Harish just explained, taking an example of a payment system, you can think about what could be the critical scenarios that could lead to the failure of payment system. So you, being the technical owners or business owners, you are the best person to identify what are your critical functions. In any complex distributed system, there could be thousands of scenarios that you want to test, but it is impractical to test everything. So you, being the owner, you can decide on the basis of likelihood of the failures, on the basis of cost implication, on the basis of any failure to meet the regulatory requirements, which ones are the critical functions and scenarios and failure modes you want to test. You want to test your upstream and downstream dependencies. You also want to see if the system has a bimodal behavior. So bimodal behavior is, for example, if you have a system that has a component or the whole system can react in two different ways under different circumstances. For example, if you have a system with a caching layer in front of the database, the same system can have a different response time or different performance under different circumstances. So you want to make sure you have covered your failure modes, including the critical ones that you want to test. After that, you want to make sure that you have reviewed the learning from the previous incidents. For example, you might have root cause analysis documents or post-mortem documents of your previous incidents. So you want to make sure that those patterns that continue to reoccur, those patterns are covered in your scenarios. And you may also want to make sure that you have reviewed your operational runbooks, because the runbooks are really important. It gives you a lot of insightful information on how your system reacts, how your people tend to work if there is any failure. Have you covered all the areas? So these are the 4 things that you do when you identify those failure scenarios. Now, after you have identified those hypothetical scenarios that you want to test, it's time to set up your target environment. After identifying those scenarios, you translate them into experiments that you want to conduct. As Harish just explained about the chaos experiments, this is the same way you translate your critical requirements or functionalities into the experiments that you want to conduct. And you also want to make sure your target environments have the right sort of observability or measurement tools embedded in that, because you want to make sure that you are measuring the right matrices. You want to make sure you are capturing all the logs that you can use for your analysis. So have those tools set. Also, you want to make sure that your security teams or the team who are going to conduct experiments, they have the right level of access. Because sometimes the tools like AWS Fault Injection Service or any tool that you might want to use for chaos experiment, sometimes those tools are not allowed from the beginning. So you want to make sure that those access permissions are all sorted. And you want to make sure your target environment is as close to production as possible. So it should mimic your production environment in terms of the infrastructure size, in terms of network load or any configuration. Because you want to make sure that you are conducting the testing in an environment that should be close to your production environment, and you're getting the right results which you want to get, or the right learnings. And finally, have those rollback and mitigation approaches ready, because if anything goes wrong in target environment, you want to make sure you recover quickly. So have these 5 things in place while planning for your chaos experiments. Harish, this was all about planning. Which tools do you recommend for customers to actually conduct those testing?
Yep. This is AWS, so we love giving customers options when they think about anything they want to do on AWS. So there are quite a few options available for you when you decide the chaos tool you want to use to effectively set up and execute your experiments. There are some really good open source tools available. Our recommendation, though, is to use the AWS Fault Injection Service, which is our chaos engineering tool. And there are 3 key reasons. The first is that FIS, as we call it, is a fully managed service. And what that basically means is that there is no heavy lifting required from you from a tooling setup perspective. The service is pre-provisioned. All you really need to do is basically get permissions for your testing and your engineering and your business teams to access the tool in the AWS console, and then set up permissions for the tool to access your infrastructure that you're testing. So once you do those couple of steps, you can basically start experimenting pretty much on the go. So it accelerates your experimentation exercise very, very quickly. If you're testing this, if you're using this against complex systems, like again the example of the payment system we spoke about, these systems can be potentially quite complex in their deployment models. We spoke about the payment system being multi-AZ. There could be connectivity to, say, on-prem systems. There could be connectivity to other SaaS systems. And trying to model a failure scenario for such a complex system can effectively be quite a significant exercise. We've been on with customer engagements where it's taken weeks just to kind of define what a failure scenario for the system would look like. The good news is that FIS basically has the ability for you to model these failure scenarios very, very quickly. In fact, we've gone a step ahead, and the FIS service team has pre-built a set of failure scenarios that are available for you to use. So based on feedback from from your teams around what are the most prominent and most common failure scenarios you would like to test, we've already built those failure scenarios for you, and we'll show that in a demo in a few minutes. But effectively, again, the fact that you have those failure scenarios already pre-built for you means that you don't have to spend a lot of time trying to define those scenarios. And then finally, if you think about when you're targeting your system and you're trying to run these chaos experiments, it's very critical that you are able to basically target these failure scenarios across all components and all layers of your architecture. So it's not enough sometimes just to test failure against the infrastructure components, but you want to also test the application, the API components that you've built potentially. So this is again a great reason for using FIS, because FIS allows you to target every layer of your architecture. So now that you've completed your testing and you have identified the outputs of your experiments, our recommendation is that you generate a test report. Now, it might seem like stating the obvious. You are potentially already, when you're doing any kind of testing, you are generating test reports. But chaos engineering is not as well known as a mechanism, and there aren't any templates or formats out there that we've seen customers have available to them when they're thinking about building a test report. So what we've done is we've put together a template that you see on the screen. We recommend you have the following elements in your test report. So the first one is the test objective. You obviously are running the resilience testing to verify a resilience goal. So what are the key resilience goals that you are trying to test? So obviously include that. What are the failure scenarios that you are introducing? Again, as I mentioned before, the failure scenarios can be quite detailed. You could also, when you're running chaos experiments, introduce failures at the people process level, not only at the tech level. So that was one of the things that Vikas mentioned. The thing that really is one of the great benefits of chaos engineering is that the operational element that you actually uncover, the operational gaps that you can uncover using chaos engineering are massively useful, because you are targeting all elements of your architecture, not just the tech element. So clearly articulate the failure scenarios that you have introduced. Any test constraints that might impact the scope or validity of the test. So again, the example that we've been talking about, the payment scenario example, if, for example, you're running your chaos experiments only against the cloud-hosted components, but not the on-prem components, or if you have connectivity to SaaS elements that you're not include those constraints. The output, obviously, whether the hypothesis that you are testing has been proven or disproven, and any gaps you've identified. And then finally, the most important element, which is the test evidence. So one of the things that DORA scenario-based testing expects you to do is to provide a clear technical audit of the testing that you've performed. And this will include technical logs, system logs, and so on. So this is where it's very important that you actually include that test evidence when you're creating your report. So if you are planning to package all of this and then submit this to your regulators, then creating this test report with these elements should be a useful starting point. Now, just to make this a bit more real, what we have done is we have a demo following this. It's a pre-recorded demo. We did not want to take a risk with all the typical elements you have with trying to run a live demo. So if the demo gods are fine, hopefully this should work. Okay, great. So what you see in front of you is the AWS console and the AWS Fault Injection Service within the console. And the scenario that we're going to run today is we are going to take the same example we've been speaking about, which is the payment system. So you have your payment system. It's a business critical system. It's deployed across multiple availability zones. And what you want to test is the same hypothesis that we had identified before, which is that because this is deployed across multiple availability zones, if there is a failure or there is an impact to one availability zone, then there is no impact to the processing of payments. And neither is there any impact to effectively the latency that end users see when they are accessing this payment system. So effectively, the expectation is that when you run the test scenario, there should be no impact to your steady state. So to do that, what we have done is we've set up FIS with that experiment. And as you can see, with it, to navigate to FIS, the Fault Injection Service, you basically navigate to the AWS console, and within the AWS Resilience Hub, you will see two elements there. One is the Fault Injection Service, and the other is the resilience management. So within the resilience testing environment, you will see we have something called the scenario library. This is back to what I mentioned at the start, where what we have done is we have basically packaged all the scenarios that we see customers frequently ask for, and that has been already made available to you. So you can see there are about 10 or 12 common scenarios that you would typically use. And we are going to use the AZ availability power interruption scenario. And what this does is basically by simulating the impact of a power interruption in a single AZ, you are able to effectively test whether your system is resilient enough when that interruption happens, if it happens in real time. So when you click on the scenario, you can see that effectively all that the failure is, the scenario is set up to run. You will find all those actions there. And then you basically click on the create template, and this is where you start creating using the scenario. The scenario, you can run the scenario across a single account or multiple accounts. Again, if your deployment of your system is across multiple accounts, then you can actually target multiple accounts at the same time. In this case, we have the scenario deployed and the infrastructure deployed only in a single account. So we're just going to use a single account. And then you click on next. And then you see basically the scenario clearly articulated. And you see two columns. The column on the left are all the failures that we are going to introduce. And the column on the right are the components, your system components that have been deployed in the account. So, for example, the failover RDS action is basically an action to impact an Amazon RDS database instance and failover the active instance to a passive instance. So effectively, it's targeting an RDS cluster, which is basically hosting our payment database. Similarly, we want to pause all network connectivity in that AZ that we are impairing. So we are going to pause any data coming in to the AZ. And then we could also stop all compute that is running in that availability zone. So effectively, depending on the system that you are testing and the components that you are using, you can effectively tweak this scenario based on the components that you use. We are not going to create an experiment template live. We have created one already. So we're going to use that just to save some time. So once you go into the experiment templates, you can see that there is already an experiment template created. So you click on that. And then when you click on that, what you can see is that the actions that have been set up. So these are all the failures that you will be introducing into the architecture, including the RDS failure and whatever other failures you want to introduce, and the actions that these failures will run against. And And the next thing you can do is you can also see the targets. So as I mentioned earlier, effectively the targets that the actions will be running against, you can see those targets. And then you can also see very helpfully a timeline of the actions. So effectively when you are running a failure scenario, you could be executing multiple different failures and you can sequence them in whatever way you want to sequence them. In this case, pretty much all the failures are getting introduced right at the start of the scenario, and then there is one failure which gets introduced slightly later. And the duration of the experiment is around 5 minutes. Now again, we obviously are not going to keep you waiting here while the experiment runs, but this is just to kind of demonstrate the point that the flexibility for you to define the duration of the experiment and the sequence is all there. So the final thing is the reporting element, and that's what we want to demo today. So FIS helpfully provides a reporting feature that effectively provides you with a technical audit of the experiment that you've performed. And we'll show you the output of that shortly. So we're going to start the experiment. You can name it whatever you like. And when you start the experiment, it shows you a prompt. Basically, this is just to tell you that when the experiment is run and when the failure is introduced, it's going to actually impact your infrastructure. So it's not a simulation. If you have set up the failure to fail over a database, the database will actually get failed over. So the experiment is now running. It starts off with showing you the status. So at this point of time, FIS is trying to identify the components it's going to run the failure against. And then once it's identified that, it goes into a running mode. And what you can do is then you can actually see in real time those failures being run against your architecture and your system components. So you can see the timeline view, and the timeline view is basically where the blue bars are the ones where the failures have started already being introduced into the system and are actually running against your infrastructure components. And once these bars turn green, so effectively at that point of time, you know that the experiment has completed. So again, the experiment is expected to run for about 5 minutes, but when we were recording the demo, we've short-circuited that so that we just show you what happens when the experiment completes. So the experiment should complete now. And you can see that the experiment status goes to green and it's completed. So at this point of time, the experiment has been run. You have simulated a AZ interruption using a power interruption scenario. And now you want to see the output of that, which is where the FIS report comes into play. So if you go into the experiment section, this is a list of all the experiments you have run. You click on the experiment and you can see, if you scroll down in the reporting section, that FIS is now generating the report in real time for you. And once the report has been completed, it will show the status as completed, and the output is available to you as a PDF file that you can download and then review and use. So what we have done is just to demonstrate the output of the report, we have extracted some elements from the report. The first element is effectively a real-time view of all the failures that were introduced as part of the experiment. So this is giving you a snapshot of all the failures that you ran on your system. And then again, the timeline view that we saw when we were running the system. So again, this is like a technical audit that demonstrates that you've actually run those failure scenarios. Then a couple of extracts from the report, which are focused on the observability elements, so the business metrics and the technical metrics. For example, in our case, we were testing a payment system, and although we were expecting no impact on the end user or the latency of the system, you can see that the shaded element, which is the duration of the experiment, there was an impact to the latency of the system. Again, any technical metrics that you've identified, you can also see outputs from there. So in this case, because when you were running the failure scenario, there was an impact on the number of database connections. Again, that is something that you can see in the output in the report. So finally, we've completed 4 stages of the session. And the last stage of that flywheel that Vikas introduced you to is around remediating your resilience issues. So you've identified the issues. Hopefully, the hypothesis has been proven true. But if not, then you've identified a set of resilience gaps that you basically need to fix. The expectation is that you will actually work with the business stakeholders to understand which remediations to prioritize, because you might identify a number of them. You will, again, one of the important things that we mentioned a number of times is that one of the best things about chaos engineering is that you will identify improvements in your operational processes. So again, as you identify operational process improvements, those can feed back into your existing operational documents like your incident management processes. And then, as our CTO, Dr. Werner Vogels, has said a number of times, everything fails all the time. There can be no system that can never fail. The only approach for you to actually ensure that you are ready for when a failure does happen is to use something like chaos engineering or resilience testing as a mechanism and to iterate through the process. So because what are key takeaways for folks from the session?
Great, thank you. It's always great to see our AWS services in action and actually explain how you can conduct those testing with the help of AWS processes. So today in this session we talked briefly about DORA. DORA itself is quite wide. We covered just one aspect of DORA, which is about scenario-based testing, which is one of the key requirements under comprehensive testing program. We also talked about how it links with chaos engineering and what is the flywheel that we have come up with to help you all and our customers and partners to conduct that scenario-based testing in your environment. Now, this won't be AWS, this won't be Summit if we don't leave you with some of the resources that you can refer to or you can learn more after this session. So the first thing we have for you is AWS DORA guide. So this is a guide that AWS published to help you understand the DORA requirements and also how AWS can help you in meeting those requirements. So I would encourage you all to take a look and read how we can help you in meeting that DORA requirements. The second is we have tailor-made a lot of resilience programs for our customers and partners. And we have created these programs to help you learn more about the resiliency of your system, but also prepare some mitigation approaches. And we have programs for different personas, like executives or your developers or your tech community. So I would urge you to maybe talk to your account SA, solution architects, or your AWS account team to learn about these programs. And you can also go to the Ask an Architect booth in the summit to get more information about these programs. The third is a technical blog that we published recently. Haresh was one of the authors of this blog. And in the blog, you can learn how you can do the testing with the help of AWS Fault Injection Service. It's essentially what we covered today, but you can take a look again for your future reference. And the last is the FIS or Fault Injection Service itself that we just demoed here. And you can do a lot of testing with the help of this service, and I would recommend you to go and take a look how this service works. So with that, I can also recommend you our own AWS Builder portal. It's a skill builder portal that you can all use for learning about cloud computing, about resiliency, about AWS services, a lot of things. So please go and create an account and access these training materials. And that, we would all like to thank you for your participation today and have a great summit and have a great rest of the day. The QR code on the right, on the left, sorry, the bigger QR code on my left. If you can please go and provide us the feedback, that would be great. It will help us to iterate and improve for our future talks. And we would love to connect with you. So these are our LinkedIn codes. We would like to get in touch with you. So please come and talk to us. We will be at the Ask an Architect booth in 30 minutes from now. So yeah, thank you. Have a great rest of the day.
Thank you.